Greetings and welcome, friends. Mr. Wadi and Mis Algebruties here, mis amigos. We were talking yesterday about point slope form, which is y minus y1 equals m parentheses x minus x1, which is a wonderfully powerful equation of a line, and all you need is a point and a slope. So for these first two problems that I'm going to do, you label your point x1, y1, your m is already labeled, and we're just going to plug it in. Plug it in. So I'm going to have y minus y1, but wait a minute. Minus a negative 4 is the same as plus 4, equals m, which is negative 6, parentheses, x minus x1, which is x minus 7. Close parentheses. That, my friends, is done. That is an equation of a line in point slope form. Super easy to write. Here's a problem that's a little bit intriguing. x1, y1 is my point. Here's my slope. And I will plug it in. And this is what I got. Y minus 2 equals, m is 4, parentheses, x minus x1, x minus 0. You could leave it as that if you want, but you also could have rewritten that as just y equals negative 2 times 4x. Because x minus 0 is just going to be x. So either of those ways are perfectly fine to work with. Here we go. We also had problems where we had to read it off of the graph. So let's see. I'm going to label one of these points as x1, y1. I'm actually going to pick this one this time because this one has positive values. Since this is on a graph, you can find the slope using rise over run by just picking any two lattice points and figuring out what is the vertical change. So this one's up 2 and over 1. So it looks like m is 2. And I can now write my equation. So y minus 1 equals 2 parentheses x minus 3. Yeah, so it's always rise over run for slope. So here's one equation you could have had. But you might be like, Mr. Wadi, oh no, I did this wrong. You might be wrong about being wrong. Maybe you were just oh so right. If you used this point, you could have a different equation that represents the same line. Equally valid solution. Y minus negative 3 is y plus 3 equals 2 parentheses x minus 1. And so both of these equations are perfectly good. For point slope form, there are infinitely many ways of writing those equations. Now, wait a minute. Pause. They told me to write it in slope-intercept form. What can I do to write this in slope-intercept form? Well, slope-intercept form, friends, is y equals mx plus b. And one of the ways you can do that is by solving either of these equations for y. I would do that by starting to distribute. So I'd have y plus 3 equals 2x minus 2. And then I would subtract 3 from both sides. And slope-intercept form will only have one way of writing it. So that is a benefit, I guess, of slope-intercept form, is if you're checking your answer, everyone knows whether they're right or wrong because there's only one answer, one way to represent that answer. For this one, let's find the slope using the slope formula. y2 minus y1 over x2 minus x1. So if I want the slope formula here, I just label my points either which way. I guess I call this x1, y1, x2, y2. Doesn't matter which way you do it, as long as you commit once you do. All right, so let's see. 2 minus 4 over negative 2 minus a negative 6. Make sure you guys are tracking here now, friends. Oh, I changed colors too soon. Equals 2 minus 4 is negative 2. Negative 2 plus 6 is 4. And that can reduce. Does anyone know what that reduces to? It's going to be negative. Someone help me out here, friends. Yeah, 2 and 4 are both divisible by 2. It's going to be a negative 1/2, which is... Uh-oh. Wow, that was a big sneeze. And also, if I could have your attention, gentlemen. Notice if I go down 1 over 2, I land on the line. Down 1 over 2, I land on the line. So I also could have found that same slope by reading it off of the graph. So let's write my equation. Y minus y1 equals m times parentheses x minus -6. Minus a -6 is the same as plus 6. So here's point slope form. Oh dear. Let's get this in slope-intercept though. We gotta distribute. So I'm gonna have y minus 4 equals. Uh-oh. What do you guys think about this one? It's got fractions. -1/2 x. Negative times a positive is negative. What's half of 6? 3. Okay, all right. So those fractions didn't end up scaring us too much. Add 4 to both sides to get y by itself. And here is the unique one way of writing the slope-intercept form, -1/2 x plus 1. What is the y-intercept based on this equation? 1. Correct. And notice on the graph that the y-intercept, right, here's the b is equal to 1. And notice that graphically, 1 is where that crosses as well. So you can find your slope using the slope formula, which is what we'd have to do. I'm just going to do one of these problems because I took the time to do the t'other that way. Let's label this x1, y1, x2, y2. Let's watch us cruise through this. So m equals, here we go, y2 minus y1. That's going to be, I guess I'll write the double negative for now, over x2 minus x1. 1 minus -2 is plus, so that's 3. 12 minus 6 is 6. What does this reduce to, friends? Yes, 1/2 is correct. And now, let's plug this and one of our points, and it doesn't matter which. You can pick. Doesn't matter. Into point, slope. Sure. So for y minus y1 equals m parentheses x minus x1. This is what we're doing. I'll draw the arrows. This is being plugged in for m. And this is why I do recommend using multiple colors. Yeah, we'll plug the 12 in for x this time. And the 1 in for the y1. Yeah, there we go. All right, so let's write this. So y minus 1 equals 1/2 parentheses x minus 12. And this is a great equation. Desmos works with this equation, right? All of these will work just dandy. But if you want it in slope-intercept form, which is what they requested, I would then distribute, whoop, whoop, like so. Y minus 1 equals 1/2 x. What's half of -12? -6. And how do I get y by itself? How do I get y by itself? And 1. So let's see. Y equals 1/2 x. Nope. So there we go, internet friends. That's all I'm doing for you today. Have a great day. Bye-bye.